All right, good afternoon, guys. So, the last couple sections that we will be looking at in Math 116 are just dealing with different ways that you can solve systems of linear equations. And just as a reminder, this is something you have seen before. I believe it would have been in Algebra 1, a little bit in Algebra 2. But a system of equations just means you have more than one equation and you're looking for the place where they intersect. Well, the most basic way to find that is to get these two equations in slope-intercept form and then go to a graph and find where they intersect. So we'll go ahead and refresh ourselves on how to do that. So if I wanted to get y by itself in that first equation, the first thing that I would do is to subtract x to the other side. Okay, so it would look like this. It would say negative y equals negative x plus 5. Okay, but then y is not quite by itself yet. There's still a negative there. Well, what that means is right now, y is being multiplied by negative 1. So how do I take care of that negative 1 that's being multiplied right now? Well, I divide it by everything. So your final step here for getting y by itself would be to say y equals, okay, divide everything by negative 1. So negative x, when I divide that by negative 1, is a positive x. Positive 5, though, when I divide it by negative 1, is negative 5. So there's my first equation with y by itself. Okay. Then we'll do the same thing with the second equation. The second equation is actually a little nicer because all that I have to do to get y by itself is to subtract the 2x to the other side, and then I'm done. So you'd have y equals negative 2x plus 1. Okay. So I'm going to just kind of maybe color code those two equations right here. Okay, or maybe put them in bold or something so that you know which two equations it is that we are looking at. All right, so those right there are in slope-intercept form. So to find where they intersect, I'm going to go to Desmos now and type them both in. So y equals x minus 5. Y equals negative 2x plus 1. And I'm going to find where they intersect, and boom, right there, they intersect at 2, negative 3. So keep in mind, when you're writing the solution to a system of equations, remember the definition of a solution is where do these things intersect. So your answer is always going to be written as a point. So your answer here, or your solution, okay, is going to be 2, comma, negative 3. Now, if you're doing this test with a graphing calculator instead of Desmos and you have questions about how to find intersections with that graphing calculator, please don't hesitate to let me know. I'm happy to help you with that. Okay? A couple other things I want to mention. So there are a few different things that can happen when you have a system of equations. Okay? Let me get this all on one page here. So the first thing that could happen is that you can have a system that can be solved. Okay, so just like the one we just did, those lines do intersect. That is called a consistent system. Now, we will look at some examples later. Here's the thing. Sometimes you can have multiple answers. So if you look at this last example here, this last picture, what has happened is you had two lines that looked different when you first looked at their equations, but when you graph them, they actually simplify down to where they're the same line. That would be a situation where you have infinitely many solutions, okay? But if there is any kind of solution, whether it's infinite or just one, that is a consistent system. But here's the thing. We've talked about parallel lines before. Parallel lines never intersect. So if you have parallel lines when you go to graph these lines, that is called an inconsistent system. And inconsistent just means a system that can't be solved. No matter how far out we zoom on this graph, those lines will never touch. So they are inconsistent. There's no solution. The other words you need to know the meaning of are dependent and independent. Dependent, okay, think about what that word means in general. It means you rely on someone else. Well, a dependent system is where when you graph the lines, they fall right on top of each other. They're exactly the same thing. Independent means there are two different lines on your graph. They might intersect, they might not, but you can definitely tell where one line is and where the other line is. Okay? So there's the meaning of those words there. All right. So that is how you solve by graphing. If you would like to solve all of these by graphing, you are welcome to do that, but I am going to show you a couple other methods that you can use. So for example 2, we are going to use the substitution method and see if we get the same answer as we did when we solved by graphing. Okay? So the first thing I want to do if I'm solving by substitution, I need to get one of these letters by itself. And it doesn't matter if it's x or y. But here's what I notice. I'm going to go ahead and get x by itself in the top equation just because that equation looks simpler than the bottom one. So to get x by itself, I move the y over with the 5 so that I get x equals y plus 5. So there's step 1. Well, here's what I've just said. X is the same thing as y plus 5. Well, then what can I do with that? That means in the second equation, instead of writing 2x plus y, I can replace x with y plus 5 and write it that way. So what I'm saying there is 2 times x plus y equals 1, but that also means that 2 times y plus 5 plus y equals 1. Those are the same thing. Look what I've done there. I've gotten myself down to where I have an equation with only one variable in it. I no longer have an equation with x and y in it. I can now solve this. So step 3 is to actually go through the process of solving for y. And when you do that, you get -3. So I'm halfway there. I know what y equals. Well, now what can I do to get x? Well, look what you said up here back in step 1. You said that x is equal to whatever y is plus 5. So x is going to be equal to, in this case, -3 plus 5. So what is -3 plus 5? Well, that's 2. And look what we got as our answer. It ought to look familiar to you because we just got it on the last question. Our solution here is that x is 2 and y is -3. And again, I write that as a point. Okay? So there's the substitution method. The last method that we're going to talk about is called the elimination method. And think about what the word eliminate means. It means to get rid of something, and that's exactly what we're going to do. So when you use the elimination method, you are adding straight down, okay? Just like it was an addition problem with just numbers. So I'd say 2x plus x. What does that give me? Well, that's 3x. But then look what happens when I go to the y's. Y plus -y. Well, they cancel each other out, so there is no more y. And then I go to the end. 2 plus 7 is 9. Here's the only time that it's really, to me, super beneficial to use the elimination method. If you look at the equations and you notice you have a positive and a negative of something, then yeah, go ahead and use the elimination method. Okay, I'll show you how to do it if you don't, but to me, that's the only time where it's really efficient to use it. So at this point, we're going to solve for x, because all we have left is 3x equals 9, and we find out right here that x equals 3. Okay, well, now that we know that x equals 3, what do I do to get y? Okay, well, I pick any one of these equations. Doesn't matter which one. I'm going to pick probably the bottom one because it looks a little easier to solve. And I know now that x equals 3. So I replace x with 3. So I say, what is 3 minus y equals 7? So what I'm saying is 3 minus what would give me 7? Well, that happens to be -4. Okay, and you can go through the process of solving that to double check me. Oh, didn't want a line there. There we go. So y equals -4. And again, I write my final answer down as a point. So my solution is 3, -4. All right, very last thing I want to show you, and again, I would not necessarily use the elimination method in this situation. I would probably either graph these or use substitution, probably graphing. But I do want you to see how to use the elimination method. So notice here right now, there is nothing that if I were to add straight down that would be eliminated. But here's what I can do. What I could do is I could multiply the top equation by 5. Okay. And I could multiply the bottom equation by 4. And I'll show you why I did that here in just a second. Well, look what happens when I do that. Okay, we'll go up here. Well, when I distribute that 5 out, I get 20x plus 15y equals 55. Okay, look what happens on the bottom here. you get negative 20x. And hopefully you notice something important right there. So you get negative 20x plus 8y equals 60. So here's the thing. What I did here was I said, okay, how could I make the x's cancel out? And I said, okay, well, 4 and 5 right here both go into 20. So how could I make both of these equations have a 20x? Well, if I multiply the top one by 5, it gets a 20x. If I multiply the bottom one by 4, it gets a negative 20x. Well, now I can add straight down, and my x's will cancel. Okay, so my x's are now gone. And what do I have left? I have 23y equals, let's see, that's 115. Yes. All right, so now I can easily solve for y. I can take 115 and divide it by 23, and I find out that y is 5. How do I get x now? Well, it doesn't, there's a variety of different ways I can do it, okay? But the easiest way is to go back to one of these two equations up top. So I'll pick the top one since it doesn't have any negatives. And now that you know that y is 5, plug in y equals 5 and see what you get. Okay, so right there, that tells me I have 4x plus 15 equals 11, and I can solve for x now. 4x equals negative 4, and x equals negative 1. And again, as always, I write my answer as a point. So your final answer here is negative 1, 5. So something I want to mention, in MyMathLab, it will tell you to use a specific method. I am not checking what method you use. What I am checking is, can you consistently get the right answer using one or multiple of these methods, okay? So as long as you are good at a couple of these, you're good to go. I'm not checking that you use specifically the method they tell you to. All right, so go ahead and get started. Let me know if you have questions.